simplifying an expression like this is where having a good basis understanding of algebra comes in handy. So basically we have two terms here. We have this term and we have this term. In the numerator we have two terms. Anything they have in common I'm able to factor out. So they have a term x squared minus 6 in common and x squared minus 6 in common. In fact, they have 5 of them in common. And then they have an x to the power in common, and here they end up with an x to the 5th times x, so they end up with an x to the 6th power in this expression. So factoring out, I'm going to be able to factor out an x squared minus 6 to the 5th power, and I'm also going to be able to factor out an x to the 4th power. So what do I have left in this yellow term if I take out an x squared minus 6 to the 5th power? I have an x squared minus 6. I have a 5, and that's all I have left in that yellow expression. And then in the blue one, if I take out an x to the 4th, I'm left with a 6 times a 2, because this is just being multiplied. So 6 times a 2, which is 12, and then I have x to the 5th times x, which is x to the 6th, but I take out an x to the 4th, so I have an x squared. And then I took out x squared minus 6 to the 5th, so I don't have any of those left, divided by an x squared minus 6 to the 6th power squared. So really this is an x squared minus 6 to the 12th power. So I took out 5 in the numerator, so I can take out 5 in the denominator. So this would be with 7 left in the denominator. So simplifying a little further, I don't know how far it goes down, but I'll just keep going. I have an x to the 4th. Let's see, I would end up with a 5x squared minus 30 minus 12x squared in the numerator, divided by x squared minus 6 to the 7th power in the denominator. See, I can simplify these two terms. I have 5 minus 12. So I could write this as, I could factor out a negative x to the 4th, and then I would end up with 7x squared plus 30 over x squared minus 6 to the 7th power. And I believe that is as simplified as I'm going to get.